Welcome to NAT. Network Address Translation for CCNA. NAT helps solve a big problem with IPv4. The IPv4 address space would have been completely consumed by the mid-1990s. The original design for the Internet required every organization to ask for, and receive, one or more registered classful IPv4 network numbers. Connecting to the Internet using only a registered network number, or several registered network numbers, worked well for a while. The main long-term solution to the IPv4 address scalability problem was to increase the size of the IP address. This one fact was the most compelling reason for the advent of IP version 6, IPv6. IPv6 can easily support every organization and individual on the planet. Many short-term solutions to the addressing problem were suggested, but 3 standards work together to solve the problem. 2 of the standards work closely together: Network Address Translation, NAT, and Private Addressing. The third standard, Classless Interdomain Routing, CIDR, allows ISPs to reduce the wasting of IPv4 addresses by assigning a company a subset of a network number rather than the entire network. CIDR is a global address assignment convention that defines how the Internet Assigned Numbers Authority, IANA, its member agencies, and ISPs should assign the globally unique IPv4 address space to individual organizations. CIDR has 2 main goals. First, CIDR defines a way to assign public IP addresses worldwide and to allow route summarization. IANA allocated all addresses that begin with 198 to one of the 5 regional Internet registries RIR, and that RIR assigned this entire range to one big ISP in that part of the world. The assignment of all addresses that begin with 198 to one ISP lets other ISPs use one route, a route for 198.0.0.08, to match all those addresses, forwarding packets for those addresses to ISP 1. This one summary route will match packets sent to all addresses in the Class C IP networks that begin with 198. The second major CIDR feature allows RIRs and ISPs to reduce waste by assigning a subset of a classful network to a single customer. What are private addresses? Some computers might never be connected to the Internet. These computers' IP addresses could be duplicates of registered IP addresses in the Internet. When designing the IP addressing convention for a network not connected to the Internet, an organization could pick and use any network number it wants. When building a private network that will have no Internet connectivity, you can use IP network numbers called private internets, as defined in RFC 1918, Address Allocation for Private Internets. This RFC defines a set of networks that will never be assigned to any organization as a registered network number. Instead of using someone else's registered network numbers, you can use numbers in a range that are not used by anyone else in the public Internet. Any organization can use these network numbers. However, no organization is allowed to advertise these networks using a routing protocol on the Internet.
What are the 3 functions that extended the life of IPv4?
CIDR, assign more specific public IPv4 address blocks to companies than Class A, B, and C networks.
Aggregate routes to public IPv4 addresses based on Worldwide Address Allocation Plan. NAT, enable approximately 65,000 TCP/UDP sessions to be supported by a single public IPv4 address. Private networks, enable the use of NAT for enterprise Internet connections, with private addresses used inside the enterprise.
Network Address Translation Concepts. NAT allows a host that does not have a valid, registered, globally unique IP address to communicate with other hosts through the Internet. The NAT function changes the private IP addresses to publicly registered IP addresses inside each IP packet. Notice that the router, performing NAT, changes the packet source IP address when the packet leaves the private organization. The router performing NAT also changes the destination address in each packet that is forwarded back into the private network. Note that with source NAT in what should be a familiar design, the destination IP address of the packet does not change during the entire trip. So, troubleshooting of IPv4 routing toward the outside network will be based on the same IP address throughout.
The return packet will first flow to the NAT inside global address. Then NAT converts the destination address to the client's private IP address in this case. So, to troubleshoot packets flowing right to left in this case, you have to troubleshoot based on two different destination IP addresses.
Static NAT. First, the concepts. The company's ISP has assigned it registered network 200.1.1.250. Therefore, the NAT router must make the private IP addresses look like they are in network 200.1.1.250. To do so, the NAT router changes the source IP addresses in the packets going from left to right in the figure. With static NAT, the NAT router simply configures a one-to-one mapping between the private address and the registered address. Supporting a second IP host with static NAT requires a second static one-to-one mapping using a second IP address in the public address range. The enterprise has a single registered Class C network. It can support at most 254 private IP addresses with NAT. The terminology used with NAT, particularly with configuration, can be a little confusing. Cisco uses the term inside local for the private IP addresses in this example and inside global for the public IP addresses. Using NAT terminology, the enterprise network that uses private addresses, and therefore needs NAT, is the inside part of the network. The Internet side of the NAT function is the outside part of the network. Cisco calls the private IP address used in the inside network the inside local address and the address used to represent the host to the rest of the Internet the inside global address. Dynamic NAT. Dynamic NAT has some similarities and differences compared to static NAT. The mapping of an inside local address to an inside global address happens dynamically. Dynamic NAT sets up a pool of possible inside global addresses and defines matching criteria to determine which inside local IP addresses should be translated with NAT. The dynamic entry stays in the table as long as traffic flows occasionally. You can configure a timeout value that defines how long the router should wait, having not translated any packets with that address, before removing the dynamic entry. You can also manually clear the dynamic entries from the table using the command clear IP NAT translation *. NAT can be configured with more IP addresses in the inside local address list than in the inside global address pool. The router allocates addresses from the pool until all are allocated. If a new packet arrives from yet another inside host, and it needs a NAT entry, but all the pooled IP addresses are in use, the router simply discards the packet. The inside global pool of addresses needs to be as large as the maximum number of concurrent hosts that need to use the Internet at the same time, unless you use PAT. Overloading NAT with PAT or port address translation. Some networks need to have most, if not all, IP hosts reach the Internet. If that network uses private IP addresses, the NAT router needs a very large set of registered IP addresses. With static and dynamic NAT, for each private IP host that needs Internet access, you need a publicly registered IP address, failing to reduce address consumption. The NAT overload feature, also called port address translation, PAT, solves this problem. Overloading allows NAT to scale to support many clients with only a few public IP addresses. The key to understanding how overloading works is to recall how hosts use TCP and User Datagram Protocol, UDP, ports. NAT overload translates not only the address, but the port number when necessary, making what looks like many TCP or UDP flows from different hosts look like the same number of flows from one host. When PAT creates the dynamic mapping, it selects not only an inside global IP address but also a unique port number to use with that address. The NAT router keeps a NAT table entry for every unique combination of inside local IP address and port, with translation to the inside global address and a unique port number associated with the inside global address. And because the port number field has 16 bits, NAT overload can use more than 65,000 port numbers. PAT is by far the most popular option. Static NAT and dynamic NAT both require a one-to-one mapping from the inside local to the inside global address.
Welcome to NAT configuration and troubleshooting. Learn how to configure the three most common variations of NAT, static NAT, dynamic NAT, and PAT, along with the show and debug commands used to troubleshoot NAT. Static NAT configuration requires only a few configuration steps. Each static mapping between a local, private, address and a global, public, address must be configured. The router must be told on which interfaces it should use NAT. In interface configuration mode, configure interfaces to be in the inside part of the NAT design and in the outside part of the NAT design. When planning a NAT configuration, you must find some IP addresses to use as inside global IP addresses. Because these addresses must be part of some registered IP address range, it is common to use the extra addresses in the subnet connecting the enterprise to the Internet. The static mappings are created using the IP-NAT inside source static command. The inside keyword means that NAT translates addresses for hosts on the inside part of the network. The source keyword means that NAT translates the source IP address of packets coming into its inside interfaces. The static keyword means that the parameters define a static entry, which should never be removed from the NAT table because of timeout. After creating the static NAT entries, the router needs to know which interfaces are inside and which are outside. The IP-NAT inside and IP-NAT outside interface subcommands identify each interface appropriately. Ensure that the configuration includes the IP-NAT inside and IP-NAT outside interface subcommands and that the commands are not reversed with source NAT. Only the inside interface triggers iOS to add new translations, so designating the correct inside interfaces is particularly important. Check the IP-NAT inside source static command to ensure it lists the inside local address first and the inside global IP address second. A couple of show commands list the most important information about NAT. The show IP-NAT translations command lists the two static NAT entries created in the configuration. The show IP-NAT statistics command lists statistics, listing things such as the number of currently active translation table entries. The statistics also include the number of hits, which increments for every packet for which NAT must translate addresses.
How can I use static NAT on my network? Let's assume we have a web server and we want to publish the server to the Internet. The web server is hosted internally. The web server is a role that can be enabled or added onto a server like FTP and many other services. The service runs by default on port 80 using TCP. When remote users request a web page, the request is sent to their default gateway. The default gateway translates the source IP address of the client computer found in the packet. The router then sends the request to the destination IP address, which in this case is the public IP address of the web server. When the packet arrives at the destination router, the router translates from a public IP address into the private IP address found in the NAT configuration.
The IP-NAT inside and IP-NAT outside interface subcommands identify each interface appropriately. Dynamic NAT uses an access control list, ACL, to identify which inside local IP addresses need to have their addresses translated, and it defines a pool of registered public IP addresses to allocate. Configure an ACL that matches the packets entering inside interfaces for which NAT should be performed. In global configuration mode, configure the pool of public registered IP addresses. Dynamic NAT configures the pool of public, global, addresses with the IP-NAT pool command listing the first and last numbers in an inclusive range of inside global addresses. In global configuration mode, enable Dynamic NAT. Note the command references the ACL and pool per previous steps. Dynamic NAT also performs a verification check on the IP-NAT pool command with the required netmask parameter. If the address range would not be in the same subnet, assuming the configured netmask was used on the addresses in the configured range, then iOS will reject the IP-NAT pool command. Ensure that the ACL configured to match packets sent by the inside host match that host packets before any NAT translation has occurred. For example, ensure that the ACL matches source address of the client point 101, not 200.1.1.101. When not using PAT, each inside host consumes one IP address from the pool. A large or growing value in the second misses counter in the show IP-NAT statistics command output can indicate this problem. Also, compare the configured pool to the list of addresses in the NAT translation table. Finally, if the pool is small, the problem may be that the configuration intended to use PAT and is missing the overload keyword. Dynamic NAT verification. Dynamic NAT begins with no NAT table entries, but the router reacts after user traffic correctly drives the NAT function. Before any users generate traffic that makes NAT do some work. The show IP NAT statistics command, which shows how many times NAT has created a NAT table entry, shows 0 active translations. The show IP NAT statistics command lists some particularly interesting troubleshooting information with 2 different counters labeled misses. The first occurrence of this counter counts the number of times a new packet comes along, needing a NAT entry, and not finding one. At that point, Dynamic NAT reacts and builds an entry. The second misses counter toward the end of the command output lists the number of misses in the pool. This counter increments only when Dynamic NAT tries to allocate a new NAT table entry and finds no available addresses, so the packet cannot be translated, probably resulting in an end user not getting to the application. NAT reacts to user traffic. If you configure NAT in a lab, NAT does not act to create translations until some user traffic enters the NAT router on an inside interface, triggering NAT to do a translation. The NAT configuration can be perfect, but if no inbound traffic occurs that matches the NAT configuration, NAT does nothing. The host telnet to the Cisco network, with a NAT router creating a NAT entry. The NAT table shows a single entry, mapping the client private address to one of the public IP address. And, the first line in the output of the show IP NAT statistics command lists a counter for 1 active translation as shown. Where the show IP NAT statistics command lists 1 miss and 69 hits. The first miss counter, now at 1, means that 1 packet arrived that needed NAT, but there was no NAT table entry. NAT reacted and added a NAT table entry, so the hit counter of 69 means that the next 69 packets use the newly added NAT table entry. The second misses counter, still at 0, did not increment because the NAT pool had enough available inside global IP addresses to use to allocate the new NAT table entry. Also note that the last line lists statistics on the number of pool members allocated, 1, and the percentage of the pool currently in use, 50%. The dynamic NAT table entries time out after a period of inactivity, putting those inside global addresses back in the pool for future use. Then, instead of just waiting on the NAT entry to time out, the example clears the NAT table entry with the clear IP NAT translation * command. At that point, another client with a different private IP address telnets to the Cisco network, and the new NAT table entry appears, using the same public inside global address.
How can I use Dynamic NAT on my network? Let's assume we have a few web servers and we want to publish these servers to the internet. These web servers are hosted internally. The web service is a role that can be enabled or added onto a server like FTP and many other services. The service runs by default on port 80 using TCP. When remote users request the web page, the request is sent to their default gateway. The default gateway translates the source IP address of the client computer found in the packet. The router then sends the request to the destination IP address, which in this case is the public IP address of the web servers. When the packet arrives at the destination router, the router translates from the public IP address found in the packet into the private IP address found in the NAT pool configuration. Keep in mind this is good for load balancing traffic since IP addresses from the pool are chosen at random.
The static and dynamic NAT configurations matter, but not as much as NAT overload configuration. This is the feature that saves public IPv4 addresses and prolonged IPv4's life. NAT overload allows NAT to support many inside local IP addresses with only one or a few inside global IP addresses. By essentially translating the private IP address and port number to a single inside global address, but with a unique port number, NAT can support more than 65,000 private hosts with only a single public, global address. Two variations of PAT configuration exist in iOS. If PAT uses a pool of inside global addresses, the configuration looks exactly like dynamic NAT, except the IP NAT inside source list global command has an overload keyword added to the end. If PAT just needs to use one inside global IP address, the router can use one of its interface IP addresses. Because NAT can support over 65,000 concurrent flows with a single inside global address, a single public IP address can support an entire organization's NAT needs. Use the same steps for configuring dynamic NAT, as outlined in the previous section, but include the overload keyword at the end of the IP NAT inside source list global command. The next step shows PAT configuration using a single interface IP address. The IP NAT inside source list 1 interface serial 0/0/0 overload command has several parameters, but if you understand the dynamic NAT configuration, the new parameters shouldn't be too hard to grasp. The list 1 parameter means the same thing as it does for dynamic NAT. Inside local IP addresses matching ACL1 have their addresses translated. The interface serial 0/0/0 parameter means that the only inside global IP address available is the IP address of the NAT router's interface serial 0/0/0. Finally, the overload parameter means that overload is enabled. Without this parameter, the router does not perform overload, just dynamic NAT. It is easy to forget to add the overload option on the end of the IP NAT inside source list command. PAT configuration is identical to a valid dynamic NAT configuration except that PAT requires the overload keyword. Without it, dynamic NAT works, but the pool of addresses is typically consumed very quickly. The NAT router will not translate nor forward traffic for hosts if there is not an available pool IP address for their traffic, so some hosts experience an outage. You can always add a check for ACLs that cause a problem. Perhaps NAT has been configured correctly, but an ACL exists on one of the interfaces, discarding the packets. Note that the order of operations inside the router matters in this case. For packets entering an interface, iOS processes ACLs before NAT. For packets exiting an interface, iOS processes any outbound ACL after translating the addresses with NAT. As you can see in the output of the show IP NAT translations command, 3 translations have been added to the NAT table. Before this command, host.101 creates one telnet connection to the Cisco network, and host.102 creates 2 telnet connections. The router creates one NAT table entry for each unique combination of inside local IP address and port. As you can see in the output of the show IP NAT translations command, 3 translations have been added to the NAT table.
How can I use PAT on my network? Let's assume we have 200 users that want to connect to the internet, but we only have one public IP address provided by the ISP. When each user requests a web page, the request is sent to the default gateway. The default gateway translates the source IP address found in the packet with the IP address of the outside interface. The port that was added to the packet by TCP is used by the router when sending the packet to the destination IP address. When user 2 connects to the internet, the router translates the source IP address found in the packet with the same IP address assigned to the outside interface, but this time the router uses a different TCP port number to keep these two flow of data separate from each other.
This debug command causes the router to issue a message every time a packet has its address translated for NAT. You generate the output results by entering a few lines from the telnet connection from the client to the Cisco network. The debug output tells you that the client now uses inside global address 200.1.1.102 for this new connection. IPv4 routing could prevent packets from arriving on either side of the NAT router. Note that the routing must work for the destination IP addresses used in the packets.
Configuring static, dynamic and NAT overload at the same time in a router. First, configure static NAT for a single IP address. Second, configure dynamic NAT for 2 IP addresses with a pool and an access list. Third, configure NAT overload or PAT for the rest of the computers found in the LAN.